Okay, so we've been looking a little bit at solving equations with algebra tiles. You might not have a bunch of these foam algebra tiles, so I'm going to just show you how you can also do this just by writing things down. I'm going to use similar to what I did last time. Just a filled in square is equal to 1. A border or outline of a square is -1. And then we'll just draw sort of a rectangle filled in is equal to x. So those will be sort of my visuals that I'm using. So if I had the equation x plus 3 equals 6, I'm going to draw that by drawing an x on the left side, 1, 2, 3 positives on the left, and then on the right an equal sign and 6 positives on the right. Now I want to isolate the variable when we're solving equations. That means we want just the variable on one side. Talked about how it's a scale, it's a balance. We always want to do the same thing. But if I get rid of those 3, then my scale is unbalanced. So if I have to do the same thing to both sides. So to get rid of those 3, I can simply remove 3 from each side. And I can just draw this by putting a line through it. 1, 2, 3. 1, 2, 3. So what I really just did there was I subtracted 3 from each side. That's how I solved it. And that leaves me with x equals 1, 2, 3. And we know that 3 plus 3 is 6, so we have solved it correctly. Okay, but I just drew the parts, subtracted what I could. Now, you could also, in this case, actually draw 3 and add 3 boxes. That would give you the same type of an answer. But right now, we'll just sort of leave it like this. Let's do x plus 2 equals -4. So another equation. I'm going to draw an x right there. I'm going to add 2 positives. I'm going to put my equal sign, and then I'm going to do 4, 1, 2, 3, 4 negatives. Now I want to subtract 2 from this side. I want to isolate the variable. However, if I'm isolating the variable, I have to remove 2 positives. I don't have 2 positives to remove. So I have 2 options here. I could either draw some pairs. That's like we're adding in pairs. And each pair, if I drew 2 pairs, then I could remove the 2 from each side. I also could just think that I'm kind of like I'm subtracting. I want to get rid of these. If I added 2 negative ones to the left side, now my scale's not balanced, so I'll also add 2 negative ones to the right side. I can then cancel out these pairs because that equals 0 and that equals 0. And this shows me that x equals 1, 2, 3, 4, 5, 6. So I had 2 options there. I could have either added some pairs to this side and then taken away, or I could have just added these negative ones to both sides, and that gives me x equals 6, which is true because 6 plus 2 equals -4. I'm going to keep solving a few more of these. X minus 4 equals 2. I'm going to draw my x. Now to draw -4, remember that's the same thing as plus -4. So I'm going to draw 1, 2, 3, 4 empty boxes. I'm going to put an equal sign, and I'm going to draw 2 full boxes. Again, at this point, I have the choice of either adding a bunch of pairs over here, and if I add a bunch of those pairs, then and I'll actually show you this time. What we could do is if I added pairs, so I could add a whole number and a blank, that's 0, a whole number and a blank. It's not the best drawn square, but you get the idea, right? And so I added the value of this side is still 2. But now I could take away 1, 2, 3, 4 from this side and 1, 2, 3, 4 from this side, showing us that x equals 1, 2, 3, 4, 5, 6. Now I could also, so again, I just added pairs and I removed the same thing. I could also solve this x minus 4 equals +2 by just wanting to cancel out these. So if I add 4 positives, and remember, if I added 4 positives to the left, my scale's unbalanced. I'm also going to add them to the right. So add 4 positives over here. But then these all these pairs cancel out. So I'd cross this out, cross this out, cross this out, cross this out. And I get x equals 6. So I get the same answer either way that I do it, and ultimately the picture ends up looking a little different, but they both give me x equals 6 as an answer. So it's really up to you to decide which method works better for you and makes more sense. We're going to do one more equation, and this one will have a couple things going on it. So we've got 2x plus negative 1 equals x plus 3. So I'm going to draw two x's on the left. I'm going to draw a negative 1, my equal sign, my x on the right, and then 3 boxes that are shaded in to represent x plus 3. Now I want to isolate the variable. I want to get, so it's just x equals something. So I'm going to take away an x from each side to start off with. Now I'm left with an x, a negative 1, and 3 positive 1s. I want to get rid of that negative 1. I can either put a pair over here and remove, or I can, again, like we did last time, I can just add a whole number here. And if I add a whole number to the left, I'll also add a whole number to the right. These cancel each other out, which gives me x equals 1, 2, 3, 4. And I could put that back in my equation to check my work. 2 times 4 is 8. 8 plus negative 1 is 7. Or, sorry. Yeah. And then I could put it up here, and x is 4. 4 plus 3 is 7. So 7 equals 7. So again, we're just showing this process of algebra tiles. You can use the foam things. You can use a pen and paper. And it's all just a good way to sort of understand what's going on in algebra and solving simple linear equations.